are doing our third assignment. Our first and second assignment are getting graded. Most of them will be done today, right? You guys are doing good work, believe it or not, right? Pat yourself on the backs. You're doing good work, right? It's only 3 weeks into programming. You're making apps already. Yes, it's not iPhone apps, but you're creating apps in the command line. You could play with it. You could show it to your relatives, your friends, right? It's awesome. So now we're doing our third app as we're going into our 4th week. It's called a command line calculator, right? So now I will say, let's go ahead and do what the instructions are saying. Fork the assignment repo. So now we will go ahead and we will fork, correct? We'll click on fork, everybody. We'll do that. We'll click on fork. Where should I fork, right? It's forking. Great. So I have my own copy. Everybody with me? Alex Paul, name. Below it says forked from, join pursuit. So we are here. What does the next step say? Step 1, fork the repo. We did that. Step 2, clone your fork to your machine. I'll go ahead and do that. I will go to the green button here. I'll click on it. I'll click on copy. I'll go to terminal. Yulia, how you doing? You forked it already? Okay, cool. I see you. So I'm going to go to terminal. I will navigate to where I want to go. For now, I will put it on my desktop, right? Be careful. Do not clone into a project that has a GitHub history already. Are we clear? We clear? Okay. So if you go into your documents, clone directly in documents. Everybody with me? Okay, so now I will get clone. Let me clear my console. I'll get clone here. Paste what I entered. I'll press enter. Great. So at this point, I will ls. I have a Pursuit Core Unit 1 Assignment 1 folder. Do we all have that? Excellent. I will navigate inside of my Pursuit Core iOS 3 assignment. I will ls into it. Right? Great. I have a calculator in there. At this point, one thing you could do, where you are currently, you could simply type open dot. 1 second. Open space dot. Open space dot. Press enter. That's going to open your directory in Finder. All right? Let's do that again. So I'm somewhere, I want to open up Finder, right? I type in open space dot. I press enter. It opens up my Finder folder. This is my Pursuit Core iOS folder. Everybody with me? Great. At this point, we should have, let me zoom in here. At this point, we should have 2 folders and a README. Yes? Everybody? Excellent. So let me go back here. Double click where it says calculator. Double click that. Double click where it says calculator Xcode Proj. Right? This here, calculator Xcode Proj, Xcode project. Double click on it to open. Takes a while for mine to load. Right? So double click on that particular folder, and we have some code already for us. So far, so good? So far, so good. Can we see in the back? Can we see in the back? Okay. If you want more space in your Xcode, do you see the 3 columns here, the 3 boxes in blue to my right? Right? So you could click on that, the furthest to the right, you could click on it. It closes up the library window. So now we have more space in Xcode. So it starts out, we have some function. It's called math stuff factory. It takes in some operation string, right? Everybody with me here? It takes in a string. What does it return? Aha. So Eddie's saying it returns a closure, right? Do we see that? Okay. So it returns a closure, right? The closure itself takes two doubles and returns a double. Do we see that? Right? It could be 4.5 plus 9. Why should your calculator not have doubles? What kind of calculator is that, right? Right? So here we have two double values coming in, one double value coming out. So far, so good. Look, we have trading closure syntax here. Hello. Here we have x and y. They're both doubles. X plus y, the answer is a double. Everybody with me? Right? I have two values, I add them together. It's a double value. That gets returned. I don't have a return keyword there. Do we see that? So this is using shorthand closure syntax. So based on the value the user enters here, I get back a closure. I get back a closure, I could perform my operation. Right? Awesome. Let us, any questions so far? So let's go through the case statement. So you have a switch, it switches on the string. I put in a plus sign, what happens? Which closure gets returned? What line? 13. Line 14 gets returned, right? If the user puts in a plus, line 14 gets returned. If the user puts in a division sign, what line gets returned? Line 20, thank you very much, right? If the user puts in a question mark, in that case, what gets returned? What's that? What line? Line 22, thank you very much. It looks for addition, subtraction, multiplication, and division. If I do not get one of those four values, go ahead and use the default value. Just add the thing up, right? Awesome. So we understand what Math Stuff Factory does. Let's make a simple case. Let's all type in our computer and test this out. I will make this smaller, sorry, in the back. So we could all see on one screen here. All right, sorry about that in the back. But we all have the code. So far, so good? Yes? All right. Make it slightly bigger here, but I want to make everything fit on one screen. Okay, so we have Math Stuff Factory. Let's go ahead and test out that function. Best way to test out a function is to write out the function and see what's happening. So let's start out by saying Math Factory. Right, passing some operation here, addition. Capture some result, let operation. All right, that's the biggest I could go for now. I want everything to fit on one screen. Cool? We good? All right, so here we have the given function. All of us should have that function, correct? Okay, what we add in now is line 26 to test out our code. Line 26 says, go ahead, use my Math Factory, pass in some addition here, and I get back some operation. Option, click on operation. What type is operation? You said array. And it's a closure, according to Andrea. It's a closure. Closure takes in two doubles. What does it return? A double. Everybody with me? Great. So now we have some operation. We could call it operation closure or closure operation. Right? Closure operation, great, we have that. Now we want to say closure operation. What does it take in? Two doubles, right? Each double is followed by a comma. Everybody with me? Same as when we call a regular function. We pass in the parameters here. So here, I want to say go ahead and add 45 plus 5. Everybody with me? So far, so good. Okay, result of call to function returning double is unused. I haven't used the value. Let's go ahead and use it. Let result equal to. What type is result? Option click on result. What type is it? It's a double. I have my answer in that result. So now I'll go ahead and print it. Right? Result of operation is result. What do we expect here? 50, according to Christian. We expect result to be 50. We pass in the addition sign. It should be 50. Let's go ahead and Command R. Right now, we're not in Playgrounds anymore. Right? We're in macOS Command Tool application. Command R will run our application. Command B will build our application for errors. So go ahead and Command B. As you type in, as you code in, Command B regularly to check for errors. Command R when you're ready to see the output of your code. So now we're ready to see the output of our code. We'll click on Command R. Run the app. Right? If I scroll up on my console, let's focus on the bottom of Xcode here. So here I have two columns, right? If you want to make your console window bigger, do we see the two bottom blue boxes to the right? Do we see the two bottom boxes to the right? Okay, so the left one, we could actually close it by clicking on it, right? And our console window gets wider. Do we see that? Okay. Now we see result of operation is 50 as expected. So our math factory works. Of course, we have more code to write here. The user needs to input what they need to input here. They input 5 plus whatever. You have to go ahead and see what operator they entered, right? Grab the operator outside, go through your math factory, and figure out what closure you got back. On that closure you got back, you perform your operation with the two operands, right? The two operands they put in, you capture that, you capture the operator, and you could get them the answer. Do we agree? With readline, we could capture the input. With going through the string, we could capture the first operand, we could capture the last operand, we could capture the operator. The operator is important, right? Because we need to know what closure we're getting back. Are we correct? Right? So I really want us to start working on that project today, right? So that we don't start on it on Thursday, like we had last week, this week. Wednesday for, wow, I love the honesty. So start on Friday, today. So you give yourself a week. So come next Thursday, you're polishing up, or you're done already. Make sure you dedicate one hour each day, at least 1 hour, Saturday and Sunday, to work on the project. I'll be watching your GitHubs. I'm watching you. Saturday morning you get up, if you normally get up at 8, get up at 7, do 1 hour of code. Start working on the calculator app, right? So Saturday, Sunday, 1 hour each, minimum. Right? Maximum should be 8 hours each day. Don't do more than that. So minimum is 1, maximum is 16. Come Monday. Right? Do the thing. All right. So we were able to test out our math factory. We were able to validate that it is correct. Right?
So we're using what you gave us, and we're basically fixing it up to where.
Yeah, fix it up a lot.
Yeah, fixing it up to
A lot, a lot, a lot.
A lot. So we're.
Because this guy does basic operations, but we need to be able to do map. We need to be able to do filter.
Okay.
Look, you're starting to go down in your seat.
No. So you want, well, I didn't read the.
Yeah, we're going to read that. We're going to go back there. I wanted to show you guys. I wanted to make sure everybody, as a matter of fact, let's stop. Let's push this to our GitHub. Right? Let's push this to GitHub. Okay. So go to terminal. Everybody go to terminal. Let me clear my screen here. And get status. Right? At this point, we all should have read. Is that correct? Is that correct? Great. Yes, no nonsense. We'll come to that. I'm not going to do that right now. Okay, so go ahead and get add everything. Right? Get add everything. Everybody is doing that now. We want to validate, we push into our fork. Everybody get add everything. Are we good? Everybody? Lilia? You good? Okay, so get add, enter, give it a commit message. Actually type get status first. Everything should be green. Get status, everything should be green, correct? Correct. Mr. Jahid. Mr. Jahid, good? Okay, so now go ahead and get commit. Give it a message. My message will be tested out math stuff factory. Right, so tested out math stuff factory method or function. Right? So I have my commit message, I press enter and get push. Get push. It should now go to your repo. Everybody? Go to your GitHub. Refresh your GitHub. Go to commits, where it says 10 commits here. We all should have the same amount of commits. Type on commits. And validate that you do have tested out math stuff factory function commit message. Yes? Everybody? Chelsea? Cool. So we tested it out, we pushed to GitHub, we forked, everything is good. We are good, we're in a good place. So we keep working on the project, we commit often, we push, come ready for submission, we have no problem. Let's go back to the instructions on the project. So click on Pursuit Core iOS Unit 1, Assignment 3. Let's go through instructions. Question 1. Right, so here, the user is entering those commands. For example, your console might look like this. 5 plus 3, right? The user enters 5 plus 3. What do you tell the user? Hello, welcome to my calculator app, the best app in the world. They enter 5 plus 3. They should get back 8. So far, so good. 5 times 3 should be 15. Right? Based on the syntax we have, 5 and 3 will give them back what answer? Well, based on this, it says exit, but based on the code, what does it do? I'm sorry? It's going to give them 8, based on the code we have. Yes. But in that particular case, you could add that ampersand to exit. Right?
So the default doesn't necessarily have to be an operation, it could be a print statement.
The default.
But if it's a
Yeah, it could be. Yeah, it could be.
the print statement could just be error.
Exactly. All right, moving to random math stuff. Make question mark a random operation. Okay, so part B, right? Look at part B. Part B says make question mark a random operation. So you need to re-engineer the code we have. When the user enters question mark, make it a random operation. Okay, that's part B. Part C, random math stuff game. When the question mark operator is used, the application will secretly perform the operation and return only the result. The user is then prompted to guess the operation used, right? Aye, very nice. So now I entered 5 question mark 3. What is the operation? Or the operator? 5 question mark 3. What's the operator if the answer is 15? If the answer is 15, what's the operator? Multiplication, right? So you answered correctly. Yes, sir. For 1B. Question mark, let's see. 1B. I have a GIF. I'll show you what the GIF looks like.
Okay.
All right. So random math game, that's that. And question 2 is interesting. Add filter, map, reduce to your application. We've seen filter. We've seen what it did. We saw map. We saw what that did. We saw reduce as well, correct? So we need to add that to our calculator. But watch, implement your own filter function. Me? Yeah. So implement your own filter function, right? We gave you what filter looks like, right? We gave you what filter looks like, the definition of it. The body, you need to do the body yourself, right? Filter takes in what? What does it filter take in? It takes an array of ints, right?
Gives you whatever you are asking for, prefix or what you're asking for.
Right? You have some filter closure here.
But if it's not a prefix to where like it's a string.
Oh, it can always be a prefix, whatever the user put in. The user wants to do whatever they want to do.
So it has to be a prefix.
No,
So
no, no.
we
We did has prefix to show us what filter could do.
But then it would also do the where it's less than 4.
Yes, exactly. So here, filter is what? What is filter? What type is filter? Yeah, but underline, what? It's a closure, right? It's a closure that takes in an int, returns a boolean. Everybody with me? Okay. What does the whole function return? An array, right? This morning we did filter. We said filter, look for fellow's name where the hash prefix starts with A. It returned us an array, correct? Filter always returns an array of those same elements. Example, what the user enters here. Example, you could do that here later. Look at these guys. Example, so the user types in filter, the word filter, into the console. They type in 152734. They type in by less than 4. Right? So some array, I want to filter it where it's less than 4. What does the user get back? 1, 2, 3. Those are less than 4. Yulia, how you doing? I see your face.
I need to see my eyes.
Yes, you could also do that. That's filter. Filter takes a condition. Well, that's our calculator. Our calculator does all types of calculations. Yeah. So the second line, it returns the filtered array. 1, 2, 3 is that filtered array. Everybody with me? Good question by Amini. Do we get that? Right? Ian, we good? Greg, I see you scratching your eye. Did something fall in it? Okay, thumbs up. All right. Cool. So here we have map, right? We love map. Map transforms things, right? What? Should I stop here? Yulia, is that what you're saying? Okay, so map. The user enters map. So you need to figure out what the user is typing. User types in map. So you take that string in, that entire string. What is the user trying to do? If the user gives me this string, what are they trying to do? I see map. We saw hash prefix. Did we agree?
Yeah.
We could totally say hash prefix map, calculate map. We have that. We've seen hash prefix before.
Well, you can do hash prefix map.
Yes. The string map.
Right.
Yes. It's a prefix to the string.
But I don't get it. What does that do?
You want to figure out what calculation you're doing.
Right. So when you do hash prefix map, so it's a map. So let's say the map is.
Whatever the user entered in your read line, you need to know what you're performing, correct?
Right.
Right. So if you have a string that starts with MAP, by performing your hash prefix on the read line, you know it's map. Cool? So then, what's next step? To go ahead and call your map function to perform that operation and give the user back the output. Cool? Okay, yes, sir.
Can I see the unit is typed in the stat format, or can I have that secure type in like something?
That format. Keep it simple.
It has to, it's going to be that.
That format, yes. Okay, so start out with that format. Afterwards, you could go crazy.
I'm not sure.
You're not sure? Okay, that's good. So keep it simple. MVP, guys. MVP, right? Minimal viable product. Get the thing working first. So, okay, so we have map here, and we all agree that that's the output of that map, correct? It multiplied it by 3, each element. 1 times 3 is?
3.
4 times 3 is?
12.
Great, so we got that there. Next up, we have reduce. We love reduce. Why not? We create our own reduce function. We love that. Right? So here, user enters reduce, right? Some string of numbers, some operation. Reduce the thing by 4, right? I start out with 4, I add, at the end I should have 26, right? That's my initial value. What's that? Why is it called reduce? Oh, it combines, it reduces to a single element. Yeah. So here we have a GIF. We love you guys. This is the operation working here, right? Enter type of calculation. You could figure out your UI, how you want to go ahead to set up the UI. The basic fundamental things we're looking for is in the requirements. As to how you make your operations, it's up to you. I have the code, I could run it, but the GIF speaks for itself, right? It shows us everything that we're doing, right? You want to keep asking the user if they want to continue. Those basic things we've done before. They enter filter 15273, right? It gives them an array. Look at that. Calculate again, yes or no? Enter type of calculation. 1 regular, 2 high order, right? Question mark, it gives them a random 49. Guess the operator. Hey, addition is correct. Excellent. Cool? So we have a GIF we could play with. So we are good. This is the conclusion of this assignment, right? 30 minutes, we're done? Excellent. Any questions? So we said higher order functions earlier when we introduced closures. It's a function that takes in a closure, right? So our function filter here, filter, it's a function, correct? It takes in a closure. It's a higher order function. Cool? And we've used filter already from Swift. So the best way is to play around with filter, see what it's doing, make sure it does the same thing that your code is doing, and you'll be in a good place. Cool? And on yes, go ahead.
Why do you not skip the user enter type of calculation?
So number 1 is the regular one, like addition, subtraction, multiplication. Those are the simple ones, right? The second one is the high order. But you could make yours dynamic, like it doesn't really matter. Whatever the user enter, you perform it. It's up to you. There's no restriction on that part. Okay, cool. So that concludes this session here.